Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 11.3, Solving Radicals Equations, Day 2. In this lesson, we're going to learn a new vocab word. It is extraneous solutions. An extraneous solution does not satisfy the original equation. You must check for these. So what we're going to do is, it's the same idea as our last lesson where we're going to isolate the square root. We're going to square both sides. Now, what's going to end up happening is sometimes we're going to have to factor, like you see in example 1 here. Okay. Before we get into that, though, what I want to talk about is I'm aware that the notes that you have are not identical to the notes that I have on the screen here. B, C, E, and F are all different. What I want you to try to do is go ahead and attempt B, C, E, and F on your own. We will talk about them in class when you guys get back. Okay. But I want you to still attempt them on your own. Use the B, C, E, and F in this video as a reference for yourself, okay? But go ahead and attempt those. We will talk about them in class. That way I make sure that you have the legit video or the legit answers to those examples later on, all right? Let's go ahead and look at the example that they gave us. We have x equals the square root of x plus 6. Just like our last lesson, we're trying to get the square root isolated, where in this case we already have that. So we're going to square both sides, just like we did before. What that gives us is x squared equals x plus 6. At this point, since I have an x squared on the left, I want to bring everything to it. So I'm going to subtract the x, and I'm going to subtract the 6 from both sides. That brings us here. We have x squared minus x minus 6. At this point, what we need to do is go ahead and factor that. So the factor tree for 6 is 1 times 6 and 2 times 3. The middle term is negative, which means my larger numbers will be negative. Those negatives need to multiply to a negative, so the smaller numbers are going to be positive. What group gets will add to -1? That will be this positive 2 and -3. So to factor this, I have x plus 2 and x minus 3 equals 0. At this point, what I want to use is the 0 property. So I'm going to take x plus 2, set it equal to 0, x minus 3, set it equal to 0. I can subtract 2 from both sides, so x equals -2. Can add 3 to both sides, so x equals positive 3. All of that is review. We've factored before, and we've solved using factoring before. So all that is review on things we've done in the past. However, what we need to do now is go ahead and check our solutions. So what I'm going to do is I'm going to take this -2 and plug it in for this x and this x. So I'm going to do that right up here. -2 equals the square root of -2 plus 6. Well, -2 equals the square root of 4. For our purposes here, when we take the square root of a number, we do not use the positive and the negative. We just use the positive. So -2 would equal 2. That is not true. -2 does not equal 2, which means that -2 is not a solution for us. I'm going to go ahead and cross that out. Now I'm going to take the 3 and plug it in for all the x's. So I have 3 equals the square root of 3 plus 6. So 3 equals the square root of 9. 3 equals 3, which is true. So my one true answer is actually x equals 3. What you're going to notice is if you ever have a square root that is equal to a negative, it is not going to work. You can every single time say that will not work. The only way that it would is if there was a negative right in front of the square root. Okay. Let's go ahead and look at another example. So I have x equals 28 minus 3x. Again, the square root of 28 minus 3x. The square root is already isolated, so I'm going to square both sides. X squared equals 28 minus 3x. Because I have the x squared, I do want to bring everything to the x squared, so I'm going to subtract 28. I'm going to add 3x to both sides. I want to write this in standard form, so it'll be the x squared first plus the 3x minus the 28. All that's going to equal 0. At this point, I need a factor, so I'm going to make a factor tree for 28. 1 times 28. 2 times 14. 4 times 7. The middle term is positive, so my larger numbers are going to be positive. I need to multiply to a negative, so my smaller numbers will be negative. If you need help with factoring, you need to come see me. Okay. At this point, I need to figure out which one will add to positive 3. Well, that would be negative 4 and positive 7. So I have x plus 7 and x minus 4 equals 0. Use the 0 property, so x plus 7 equals 0. X minus 4 equals 0. I can subtract 7 from both sides and add 4 to both sides. So x equals negative 7 and x equals positive 4. Now I need to go ahead and check my solution. So you can do this in a couple ways. I would like you for the first day or so to go ahead and show your work here. But afterwards, what you can do is you can start just typing it in the calculator. So the first one is negative 7 equals the square root of 28 minus 3 times negative 7. So this would be negative 7 equals the square root of 28 plus 21. If you remember what I said up earlier, if I ever have a square root that's equal to a negative number, I know that's not going to work, so I know that negative 7 is not going to be one of my answers. Now I want to put 4 in for all the x's. So 4 equals the square root of 28 minus 12. This, 28 minus 12 is 16, so I have 4 equals the square root of 16. 4 does, in fact, equal 4, so my solution is good. Okay? Let's continue here. I have x equals x plus 2, so I'm going to square both sides. That's x squared equals x plus 2. I need to move everything over. So x squared minus x minus 2 equals 0. To factor tree 2, I have 1 times 2. The middle term is negative, so my larger number is negative. I need to multiply to a negative, so my smaller number will be positive. I have x plus 1 times x minus 2 equals 0. I'm going to set those equal to 0 using the 0 property. I can subtract 1 from both sides. I can add 2 to both sides. So x equals negative 1 and x equals positive 2. At this point I need to check it again. So I'm going to take the negative 1, put it in for all the x's. So negative 1 equals the square root of negative 1 plus 2. I have a negative equal to a square root. I know that's not going to work. Now I'm going to take 2 and put it in for x. So 2 equals the square root of 2 plus 2. 2 equals the square root of 4. 2 does in fact equal 2. So x equaling 2 does work. On to C, final problem here. Or not final problem, but another problem that we're going to do. We're going to square both sides again. So I have 5x minus 4 equals x squared. I need to subtract my 5x, add my 4 to both sides. All that'll cancel. So I'm going to subtract the 5x, add the 4. 0 equals x squared minus 5x plus 4. At this point, I need to go ahead and make my factor tree of 4. So that would be 1 times 4 and 2 times 2. The middle term being negative tells me my larger number is negative. It needs to multiply to a positive, so my smaller numbers will also be negative. What of those options that I have will add to negative 5? Well, that would be negative 1 and negative 4. So I have x minus 1 and x minus 4. Set them equal to 0. Can add 1 to both sides. I can add 4 to both sides. So I have x equals 1 and x equals 4. At this point, I do not have a negative, so I can't just jump straight to a conclusion that one of these won't work. So I need to put 1 in for all the x's. So 5 times 1. Sorry about that. So 5 times 1 minus 4, the square root of 5 minus 1, or 5 times 1 minus 4 is equal to 1. Well, 5 times 1 is 5. 5 minus 4 is 1. So the square root of 1 is 1. My answer, x equals 1, is good. Now I need to check my 4. So I have the square root of 5 times 4 minus 4 equals 4. Well, 5 times 4 is 20. minus 4 equals 4. 20 minus 4 is 16. The square root of 16 is 4, and that does equal 4. So both answers in this case are good. I do not have any extraneous solutions. Okay? On to D. And a little bit of review here. What I need to do on D is go ahead and subtract the 5 from both sides. I end up with 3x. The square root of 3x plus 4 equals negative 2. Now that I have the square root isolated, I can square both sides. That will leave me with 3x plus 4 equals positive 4. Remember, when you square a negative 2, it will be inside of parentheses because I'm squaring the whole thing negative 2. I'm not just squaring the 2 and leaving the negative out front. At this point, I can subtract 4 from both sides. 3x equals 0. Divide by 3. X equals 0. You need to go ahead and check this solution as well. So I take the square root of 3 times 0 plus 4 plus 5 equals 3. I do not want to put my number in for x in anything other than the original equation. I'm going to plug it back into the original equation only, okay? And I'm not going to move anything across the equal sign at this point. I'm just going to simplify the numbers that I have. So 3 times 0 is 0 plus 4 plus 5 equals 3. Well, 0 plus 4 is the square root of 4 plus 5 equals 3. The square root of 4 is 2 plus 5 equals 3. Well, 7 does not equal 3, meaning that I have no solution. Find out that x does not equal 0, so I have no solution. Okay. On to E, which is back like the problems that we've been doing up top. I need to square both sides. So I have x squared equals 3x minus 2. I'm going to subtract 3x and add 2 to both sides. So x squared minus 3x plus 2 equals 0. I need a factor at this point. The middle term's negative, so my larger number's negative. It needs to multiply to a positive, so my smaller number's negative. So I have x minus 1, x minus 2 equals 0. Can set those equal to 0 using the 0 property. Add 1 to both sides. Add 2 to both sides. So x equals 1, x equals 2. Again, I have to check these answers. I can't assume anything when I'm working with these problems, okay? So I'm going to put 1 in for all the x's. So 1 equals the square root of 3 times 1 minus 2. 1 equals the square root of 3 minus 2. 1 equals the square root of 1. So 1 does in fact equal 1. Mean my answer is good. I'm going to go ahead and put 2 in for all the x's. So 2 equals the square root of 3 times 2 minus 2. 2 equals the square root of 6 minus 2. 2 equals the square root of 4. 2 equals 2, which is also true. And I am done. Both my answers are good. On to F, it is again review from our last section. When I have either square root by itself, I can go ahead and square both sides. So end up with 8 minus x equals x plus 14. At this point, I want to move the smaller variable. Well, the smaller variable is the negative x. In order to move it, I will add the x to both sides. Since I move the x to the right, I want to move the number to the left, so I'm going to subtract the 14. Well, 8 minus 14 is negative 6. X plus x is 2x. You can go ahead and divide by 2. Negative 3 then would equal x. Again, I want to check this. I'm not sure. I can never assume anything. I want to go ahead and check to see if this will work. So I take the square root of 8 minus the negative 3. That's from this spot right here. There's a negative in front of my x. Well, my x is negative 3, so I need to have both negatives there. And then negative 3 plus 14 for the other side, the square root of negative 3 plus 14. So 8 minus a negative 3 is the same as 8 plus 3, which is 11. So I have the square root of 11 is equal to the square root of negative 3 plus 14 is also the square root of 11. The square root of 11 is equal to the square root of 11. So my answer is good. Remember, the most important part of this worksheet, of this note sheet, this lesson, is we're going to have to factor some. You do still want to get the square root isolated and by itself. Once you have it isolated, then we can square both sides. Once you square both sides, sometimes you're going to have to factor. Sometimes it's a straight ahead one-step or two-step equation. Just once you get to your answer, you need to plug it back into the original problem to make sure that it is a legitimate answer and not an extraneous solution. If you have any questions on this note sheet, please make sure you ask me tomorrow. Thank you very much for watching the video, and have a great day.